In this video, we're going to be learning how to multiply with rational expressions. So multiplying rational expressions actually relates directly to how we multiply with fractions. So here you'll see we have a over b times c over d. And when we multiply rational expressions, all we're simply going to need to do is just like when we multiplied with fractions, multiply across with the numerators, multiply across with the denominators. The only difference here is we're going to have to use our simplifying and factoring techniques to help us out, because we're going to need to then simplify this rational expression, and we know that the way to simplify the rational expression is to use factoring. So essentially what we're going to do is we're going to combine factoring along with simplifying fractions. So we're going to use what we know about fractions. And then we're going to fully simplify this new rational expression. So for this first example here, we can see that we have a fraction times a fraction. Now, because we don't have something like a binomial or a trinomial, we don't really need to factor it to start. So what we're going to do is we're going to start off by simply multiplying the two numbers in the numerator together, and then multiplying the two numbers in the denominator together. So if I multiply in the numerator, 10 times 12 gives me 120. Then from here, I have x to the third times x to the fourth. Well, I know that when I multiply two items that have a common base, we simply add the exponents. So I have x to the seventh. And then I have y to the fourth times y squared, which is y to the sixth. Then from here, we look in our denominator, and we see that we have 5 times 8, which is 40. We then have x squared times x to the third, which is x to the fifth. And then we have y to the third times y to the seventh, which is y to the 10th. So from here, now we use our simplifying techniques. Now you have two options here. You can either use what you know about exponent properties. So I'll show you both ways. So first, if we just start with the 120 over 40, we know that that simplifies to be 3 over 1, because 40 goes into 120 3 times, and then 40 goes into itself once. Then from here, we use our exponent properties. So we take 7 minus 5, which leaves us with x squared in the numerator. And then we have 10 minus 6, which leaves us with y to the fourth in our denominator. So then from here, we are done. You can simplify this to simply be 3x squared over y to the fourth. Now, if you don't like using the exponent properties way, you can also break these up. So instead, you could break this up into, noticing, okay, we have a 5 and a 7. So you could break up the top into 120 x to the fifth, x to the second. Then we know that we can break this one up into y to the sixth, y to the fourth. So we leave this y to the sixth in the top alone, then change the bottom to be 40 x to the fifth, y to the sixth, y to the fourth. And then you can look for items that they have in common. So cross off the x to the fifth, cross off the x to the y to the sixth, and then you're simply left with, after we simplify 120 over 40, which becomes 3 over 1, we're left with x squared over y to the fourth. So it doesn't matter if you like to use your exponent properties way, or if you like to break it up and then cross off what they have in common. Either way will work. So the second example here is going to be a little bit more complicated. You'll notice that we have everything ranging from binomials to trinomials to monomials. And so we're going to need to use our factoring before we start multiplying across the numerator and multiplying across the denominator. So let's look at each one individually. So if we start right here, we have 4x squared minus 4x. Now I notice, because there are two terms and they each contain x, that I can factor out a greatest common factor of 4x. So I'm going to rewrite this one right here to be 4x factored out times x minus 1. So this one can be rewritten to be 4x times x minus 1. Then if I look at that second one there, we notice that we have a trinomial, so we're going to try out our ABC strategy to see if that will help us factor it further. So we have A is equal to 1, B is equal to 5, and C is equal to a negative 24. So I need two numbers that multiply to a negative 24 and add to 5. And because my A value is 1, I know that I can use my shortcut here. So two numbers that multiply to negative 24 add to 5 are a positive 8 and a negative 3. So I know I can rewrite this one right here to be x plus 8 and then x minus 3. So I can rewrite that one. Now if I look at the third one down here, again I notice I have a trinomial, so that one I can use the ABC strategy on. So I have A is equal to 1, B is equal to 7, and C is equal to a negative 8. And I need two numbers that multiply to a negative 8 and add to 7. Well, I look and I notice that I have two numbers that do multiply to negative 8 and add to 7. That would be a positive 8 and a negative 1. And because I have an A value that is equal to 1, I can use my A value shortcut and just write x plus 8 times x minus 1. So we always start off by turning these into their factored form, because that will make the multiplication process as well as the simplifying process quite a bit easier. So now what I'm going to do is, because this is multiplication, I'm going to multiply the numbers in the numerator and then multiply all of the terms in the denominator. So here my new fraction turns into 4x times x minus 1 times x plus 8 times x minus 3 all over x plus 8 times x minus 1 times 4x. So at this point I've used factoring to turn this into a multiplication problem, and as a result, because it's all multiplication, I can cross off any terms that they have in common. So in the numerator I see that they both have a 4x and a 4x, so those can be gone. I see that they both have an x minus 1 and an x minus 1, so those can be gone. I see that they both have an x plus 8 and an x plus 8, so those are gone. And all I'm left with here when I simplify this is x minus 3 in my numerator. Now what I have to keep in mind, as I did before, is that when I solve this, yes, I'm able to cross off any terms that they have in common, but I also need to note that everything in the denominator that gets crossed off, I need to account for the fact that anything in the denominator that I crossed off can't equal 0. So we can't have x plus 8 equals 0, or x minus 1 equals 0, or 4x equals 0. So here, x can't be negative 8. Here, x also can't be a positive 1. And x also can't be 0. So our final answer is going to be x minus 3 is the simplest form, but then x cannot be negative 8, positive 1, or 0. So let's try one more example here. So again, I'm going to start off by simplifying each expression that I have in a numerator or a denominator and turning those into their factored form. So here I notice that there are two terms and they have a greatest common factor of 3x. So if I factor out a 3x here, I end up with 3 minus x. Then this next one here, I look at it and I'm going to try to use the ABC strategy. So I have A equals 1, B equals 3, C equals 9. So I need two numbers that multiply to 9 and add to 3. And as I start thinking through all of my factors, there really isn't anything that multiplies to 9 and adds to 3. So this one I'm going to put a little question mark by and say I'm not sure that that's fully factorable. And so I'm going to leave it as is for right now, just put some parentheses around it, and then maybe come back and look at it in a little bit. Then from here, if I look down at the third example, I notice that this is a difference of cubes. And remember, when we have a cubed minus b cubed, that really turns into a minus b and then it's a squared plus ab plus b squared. So that's my difference of cubes equation that I'm going to use for this particular simplification. So here I can rewrite this to be x cubed minus 3 cubed, so I know what a and b equal. And then as a result, I can use my difference of cubes to simplify this to be x minus 3, and then it becomes x squared plus 3x plus 9. So got that all simplified out now. And then finally, this last one, we can see that we have 3x squared minus 15x. So for this one, we can actually simplify just like we did with this first one up here by factoring out the greatest common factor. So here I notice that the greatest common factor is 3. So we have 3x, and then we have x minus 5. So we've got this simplified out. Let's try to all write it together so we can look at it in another way. So we're going to multiply everything in the numerator together and everything in the denominator together. So I have 3x, and then I have 3 minus x, and then I have x squared plus 3x plus 9, all over x minus 3 times x squared plus 3x plus 9 times 3x times x minus 5. So I have a lot going on. So now I'm going to start to simplify this by canceling out anything that they have in common. So I notice that they have these two items in common. So I'm going to make a note off to the side as I cancel anything off that x squared plus 3x plus 9 cannot equal 0. So I know that that can't equal 0. I also note that 3x and 3x cancel off. So I note that, okay, 3x equals 0 would result in x is 0. So I note that x also cannot equal 0. That's another thing I've crossed off. Now what I'm left with here is 3 minus x over x minus 3 times x minus 5. And the last thing I note here is that these two right here look really similar. I mean, 3 minus x and x minus 3. Now, what I can do here is in this numerator part, what I can actually do is I could factor a negative 1 out of this. And if I factor a negative 1 out of this, this is going to become a negative 3 because it'd be the opposite of 3. And then it's going to become a positive x. And so if I factor out a negative 1, I can then rewrite the inside of that parenthesis to be x minus 3, which then matches what's down here. So if I notice I have something that's very similar, I can actually rewrite that. So this now numerator is now negative 1 times x minus 3 all over x minus 3 times x minus 5. So you might have to do some algebra manipulation here to make sure that you're fully simplified, because these two do in fact cancel out. We then have to note that the x value cannot equal 3 as well. And so our final answer here actually becomes just negative 1 over x minus 5, and then x cannot equal 0, x cannot equal 3, and x squared plus 3x plus 9 also cannot equal 0. And we could solve that out, but we're just going to leave it just as is.